Hello, welcome to Super Easy Physics and Mathematics. Today, we're going to be looking at the solution to IGCSE Physics, Paper 2, Variant 2, May-June 2024, solved by Orisheje Matthew. This question contains 40 MCQ questions, and the duration is for 45 minutes. Then the major constants that we are going to use in this exam is acceleration of free fall 9.8 meter per second square. So let's go in, get your paper, your pencil, your pen, and your calculator, and let's walk through the question. Alright, question number 1. A student wishes to measure accurately the volume of approximately 50 cm cube of water. She has two measuring cylinders, that is this and this. A large one which can hold 100 cm cube and a small one that can hold 50 cm cube. The water forms a meniscus where it touches the glass. So you have the big measuring cylinder and the small measuring cylinder. Which cylinder and which water level does the student use to measure an accurate result? So the answer to this is C. So let's go to the second one. The motion of an object is represented by speed-time graph as shown. So you have the speed and then you have the time. Which quantity is equal to the area under the graph? So the area under the graph is equal to distance traveled. That is C. The acceleration is the slope. So the slope of this graph will give you acceleration of the motion of the particle. Okay, and then basically that is what the information that we have here. So let's move to the next one. An astronaut, question 3, has a mass of 80 kg, is standing on a planet with gravitational field strength of 3.8 Newton per kilogram. What is the weight of the astronaut on this planet? So for us to be able to calculate the weight of the astronaut W is equal to the mass multiplied by acceleration due to gravity, which is equal to 80 multiplied by 3.8. And that is going to give us 304 Newton. So approximately the answer is B. A sealed container of volume 2000 cm3 contains air at high pressure. The container is placed on a top band balance. Then the balance reads 200 grams. So the mass is 200 grams. Okay. And all the air is removed by a vacuum pump and the balance reads 196 grams. So if you want to look at the mass of air, it's going to be minus 196 grams. So that will give us 4 grams. So that is the mass, and then the volume of gas is 2000 cm3. So what is the density of the pressurized air? So density is equal to mass divided by volume. So which is equal to 4 divided by 2000. And then this will give us 0.002 gram per cm cube. 0.002. So the answer is A. So let's go to question 5. It's on equilibrium of forces. So in which situation is it possible for the three forces shown to be in equilibrium? So this cannot be in equilibrium because this one is going to produce a clockwise moment. And then if you look at this, at DB you have just only this and this, it will have been in equilibrium. It's not necessarily in equilibrium because the point of pivot where it is said, so the force upward is more than the force downward. So this one is not correct, this is not correct, this is not correct. Okay, total upward force equal to total downward force. So this is the correct answer to this. So I want you to subscribe and like and share the video with your classmates. Alright, so let's go to question number 6. Question number 6. A gymnast jumped down from a high piece of apparatus. She gradually bends her knee as she lands. What effect does this have? So this is, you are talking about force. The force is equal to delta mv all over delta t. So if t increases, then F reduces. So the consequence of her bending her feet is that it will eventually reduce the force of impact as she lands. So the answer to this, she will experience a smaller force because bending a knee increases the time of landing. So the answer to question number 6 is D. So let's look at question number 7. The table gives 4 resources and state whether the main source of energy for the resources is the sun. Which row is correct? That's question number 7. This is wrong, this is wrong, this is correct, and then this is wrong. Wind is solar, and then the water head behind the dam, the source of the energy, and then the main source of energy is the sun. Yes, this is correct. Okay, so number 8. The equation, the pressure is equal to density multiplied by acceleration due to gravity multiplied by the depth, can be used for a liquid. What is the meaning of the symbol rho? So rho stands for the density of the liquid. That is B. So that is the density of the liquid. So if you want to put this in pictorial form, so if you have like a swimming pool and then you have a fish under, okay, let's have this. You have this fish and then the water level is from here. Then we can measure the depth, okay, which is D. And then once we know the density of the water in the pool, so the density of the water, then we can now calculate the pressure that is acting, that the fish will experience at that point. So the pressure is equal to density times the gravity then times the depth. So that is how to calculate this pressure under liquid. Okay, question number 9. So let's look at question number 9. What is the correct term for each change of state? So in this case, you have a change of state. You have from liquid to solid, and then from liquid to gas. From liquid to solid, this is solidification. And then from liquid to gas, that is evaporation. So liquid to gas, solidification, evaporation, that is C. Okay, so if we want to explain this further, so you have solid, then you have liquid, and then you have gas. So this is melting. So you have melting, then you have evaporation, then coming back, this is condensation, and then coming back, this is freezing, which is the same thing as solidification. So you have that. Okay, so let's look at question number 10. Question number 10. Extremely small polygrain in water are viewed through a microscope. The grain are seen to move continually and randomly. What is the reason for this random movement? So let me just show you what actually happened in this very particular situation. So let's see this. You have a microscope. So you have the slide, then you have polygrain, put it on top of the water, then you can shine light from the source, from the side, okay, of the slide into the microscope. So the light that is coming, and then if you look at the polygrain, so here you have the tiny polygrain, which is black, then the white particles are invisible. We can't see this one. These are the molecules of water. So as they bombard the polygrain, then you see the motion of the polygrain is moving. So for example, if this particle here, if this particle should strike this polygrain, or okay, let's use this one that is directly on it. So if this one strike it, it will push the polygrain down, okay, to this position here. And then this one will strike it, it pushes this way, and then this one will strike, so it push. So if this one strikes it, it pushes it this way. So you see that it goes in zigzag direction. So what is the reason for this? Is because the pollen grain is being bombarded by the invisible particle of water. So what is the essence of this experiment? This one is an indication that water contains particles that are in continuous motion. So question 10, what is the reason for the random motion? So number 10, the grain are moved randomly, okay, by the water molecules that are striking it. So question 11, which graph shows how the volume of a fixed mass of gas at constant temperature varies with its pressure? So the correct answer is D, because the pressure of a fixed mass of gas is inversely proportional to the volume at constant temperature, which is the condition given to us. So if you have this, and then if you now say, okay, volume as a function of pressure, okay, as the pressure increases, then the volume, as the pressure increases, then what happens to volume? Volume reduces, okay. So if you look at it, then as the volume decreases, then pressure increases. So it's inversely proportional. So based on that, this is the correct graph that is representing this. This graph is wrong. This graph can only be correct if you have 1 over V over 1 over P. Okay. Now, this one is tend to talk about Charles' law, but this is not, that is volume and T. But, well, let's just leave it. Let's concentrate on the Boyle's law, which is being represented by option D. So, and this is pressure of a fixed mass of gas inversely proportional to the volume was Boyle's postulate. So this is Boyle's gas law. Okay, so let's look at question 12. Which effect is caused by the thermal expansion? It is a railway buckling. So this is effect of thermal expansion. Okay, with this code here, you can have a live chat with me. If you have any question, you can contact me by scanning this code here. Subscribe to Super Easy Physics and Mathematics. Keep the comments going, and as you keep preparing for your exam, we are here to help you. So let's go to question number 13. Question number 13. The temperature of water at the bottom of a waterfall is greater than the temperature of water at the top. So this is pictorially, this is what we are talking about. So if you have a waterfall, and then the water falls from this mountainous part, then it comes to the top, to the bottom here. So the water drops from this top, okay, and then the water flows and then drop. So we have this top part, and then we cannot talk about the distance. So from here and then to this point here, so we have the height, okay, and then the energy at here is mgh, potential energy. Okay, the potential energy is converted to thermal energy, which is mc delta t. So if you look at it, if you equate that, you have mgh is equal to mc delta t, so which is the temperature rise. So based on this, and then the mass is equal. So if the mass is equal, the mass is out, the water that drops. So then we can now have, we are looking for delta t is equal to gh divided by C. So substituting, so we have 9.8 multiplied by, what is the height of the water? 21 meter, divided by specific capacity of water, which is 4,200 joule per kilogram per Kelvin. So if you divide that, okay, it's going to give us 0.49 degrees Celsius. So 0.49 degrees Celsius, so that is B. 0.0, yeah, sorry, that is 0.04, 0.049. Okay, an ice cube is placed in a beaker and is heated. The ice melts to form water. So we have this, so we have ice cube. So let's have it here like this. We have ice, then we have water, then you have gas. Okay, so if it melts, so the ice melts to form water, okay, and then this process involves absorbing, so energy is absorbed, then it goes to gas, then energy is also absorbed by water, okay, energy is added to the water. Then if the gas condenses to water, so energy is released, okay, energy is released. So the steam condenses on a cold window in the room, so this one will release energy to the environment, so to the environment. Okay, so with that, which of them releases energy? So is the condensation process. So question number 14 is D. So let's go to question 15. Okay, so the class is shown a polystyrene cup. The polystyrene is in a thick plastic. The polystyrene is a thick plastic with a lot of tiny air bubbles in it. He asks the class why the cup is so good at keeping hot drink warm. 3 suggestions are made. The polystyrene contains air, which is a poor thermal conductor. So this assumption is correct. Then the air is trapped in a tiny bubble so that very little convection is possible. That is correct. Then the plastic is a poor conductor, is a poor thermal conductor. Correct. So which suggestions are correct? So the answer is what? 1, 2, 3. So the correct answer is A. Subscribe, like, and share the video. Question 16. 2 samples of the same material are made of the same mass but different surface area. The same mass, so take note of the condition given. The same mass, same material, but different surface area. So that is the condition there. Now this surface area of Y is larger, and then the surface area of this is smaller. Okay, each is allowed to cool down and then they were heated to the same temperature, then left to cool to room temperature. Which of the following correctly compare the decrease in the internal energy and the initial rate of cooling for the same? So internal energy decrease is a function of the temperature. So since the cooling, it was heated through the same temperature, it means that the energy in X and energy in Y is the same. So both of them have the same amount of energy. Now, internal energy is the same because the temperature, the average total kinetic energy as a function of temperature is the same. Then, the rate of cooling, the bigger the surface, the higher the rate of cooling. So what is going to happen is that number 16, so Y cool down faster than X because of the large surface area. So the correct answer here is D. So let's go to question 17. Question 17. In which type of wave is the direction of vibration parallel to the direction of travel, the propagation of the wave? So if you look at this one, so this one is what? When the direction of particle vibration in the medium is parallel to the direction of propagation. So that is example of longitudinal wave. So the longitudinal wave among these four given to us, this is transverse, and then water wave is transverse. So the only longitudinal wave here is the seismic primary wave, so which is B. So question 18. Wave in a repo tank are diffracted as they pass through a narrow gap. What can be done to make the spreading due to the diffraction greater? So if you want to have higher diffraction, so you have this, there is a gap, and then this gap here, a narrow gap, and then so if a wave is coming, then for it to experience diffraction, the wavelength, that is the gap, and then the wavelength between the incoming wave, the wavelength must be proportional to the gap. So if you reduce this, then the spreading will increase. So if you want to calculate wavelength, is equal to velocity over frequency. So if this to reduce, that means frequency will increase. So the bigger the frequency, then the wavelength of the wave reduces. So based on that, what is going to be the correct answer? So decrease the frequency of the wave and keep the speed constant. So number 18 is A. So right, so let's see to finish this part 1. So we're going to answer the first 20 questions just to make the video, the timing easier for you to follow. So this one is about image formed by plane mirror. Okay, and I is looking at the image on the page, and so this is the image that is formed. So this is letter G. So if this letter G is on the paper, so what are you going to do? So we have the I. What is flipped, lateral inversion. What is the appearance of the image of G seen by the eye? So I talk about lateral inversion. That is number 19. The correct answer is going to be D. So quickly, let's revise image form, the property of image formed by plane mirror. So 1, The image formed by plane mirrors, what are the properties? Let's quickly review it. The image is at the back of the mirror, so you cannot be formed, so they are virtual. Okay, the image is upright. Image formed by plane mirror is upright, that is erect. Then the image that is formed by plane mirror, the distance of the image from the mirror is the same distance as the object, so U equals to V. So we have image distance and object distance is same. And then okay, the image is undergo a vertical flip, so that is what we call lateral inversion. Lateral inversion. Now lateral inversion, that means if I put P in front of the mirror, P, then we're going to see 9. If I put B, then it will appear as D. So this is what we call a horizontal flip. So if I put D, I will see B inside as the image. If I put P, I will see 9. If I put 9, I will see P as the image. So this is called lateral inversion. So basically, those are the... Okay, so this last one here to end the first 20 questions. Now, in this very particular diagram, one thing I want you to know is that the image is always measured from... You measure it from the normal. So it's the normal. So you measure from the normal. So what is the angle of incident? I. That is from here to here is 90 degrees. So I is going to be 90 take away 60, which is what? 30 degrees. So that is I. Then you get your angle of refraction. So which is going to be 90 take away 78, which is equal to 12. So the refractive index N is equal to sine I over sine R. So which is equal to sine 30 degree over sine 12 degree. So if you carry out the calculation of that, and that will give us about 2.4. So the answer is C. So with that, we come to the part 1 of this video. I want you to subscribe, like, and share this video. So stay tuned. We'll come again and look at the part 2, where we are going to treat question 21 to question